Hello there, welcome to Lower 6th Further Maths Pure Core 1 past paper, June 2012. Here we're looking at question 3. This is new to Pure Core 1, so I've added this question in myself. So, what we're looking at here is some integration. It's going to be a solid formed by a revolution of 360 degrees around the x-axis. And we're in between two different curves, the y equals 2x plus 1 and the y equals 4 minus x squared curve. So we're going to have to separate this first. Okay, so we want to find the volume that's created when this revolution is rotated 360 degrees. So what we're going to have to do is we're going to have to split our revolution into a part A and a part B. Part A is going to be using this line or this graph to integrate around, and part B is going to be using this line to integrate around. So what we have to do first is to find this coordinate here, the x coordinate where the two graphs then overlap. So what we want to do to start with is to set 2x plus 1 equal to 4 minus x squared. So quadratic, so take everything over onto one side and solve that quadratic. So either x equals minus 3, looks like that will happen down here, as we're not interested in that solution, we are interested in the x equals 1 solution. So it looks like this coordinate here is the coordinate 1, so what we're going to have to do is split up our integration from 0 to 1 and then 1 up to 2. So the integration is going to be, for part A, is going to be pi times the integral from 1 to 0 of the line y equals 2x plus 1, because that's the curve that's bounding it. But remember, it's y squared, the formula, so we have to square that function as well. So what we then need to do is expand those brackets. That would be 4x squared plus 4x plus 1 dx. And then the next thing we need to do is to integrate. So remember, it's increase 1 on the powers and divide by that new power. So increase the x squared to an x to the 3 and then divide by that number 3. Same with the 4x. The x is now 1, so we increase that 1 to a 2 and then we divide through by 2. And for the 1, x has a power of 0, so now it has a power of 1. And we bound that in between 0 and 1. And then we've got to go ahead and work this out. So whip out your calculator. You can actually go straight from this part down here and find the value of that integral, and that's 13 1/3 times pi, because we haven't included pi in this calculation here, so I'll add that in later. Okay, next we need to do part B. So part B is going to be pi times the integral, and this time we're working in between here to here, so that's going to be in between 2 to 1, and we then need to take the curve that that's bounded by, 4 minus x squared, and square it, because that's the formula. It's pi times the integral of y squared dx. So let's expand these brackets. 2 to 1 of 16 minus 8x squared plus x to the 4 dx, and integrate. So that's going to be 16x minus 8x, the 2 turns into a 3 and we divide by the 3, and then that 4 turns into a 5 and then we divide by the 5. And that's going to be in between 2 to 1, so calculate that again, and we get 53 over 15 pi. So all that's left for us to do, we need to add together these two volumes, so volume A plus volume B, and get your calculator out, so 13 over 3 pi, add 53 over 13 pi, and you get 24.7 to 3 sig figs. And that's the answer to the question, 5 marks.